Hello everyone, this is Ma'am Amano and this lecture video is all about index of refraction or calculating the index of refraction. So index of refraction is defined as the measure of the bending of a ray of light when passing from one medium into another. This is also known as refractive index and can be calculated by measuring the speed of light in a vacuum over the speed of light on a given material. So when we talk about refractive index, so for example, the light travels in a vacuum. Okay, and then it will pass through into a water, let's say. So, when the light, okay, passes from one medium into another, it bends. So, it measures how much is the bending of the light. So, that is the refractive index. Then we have here the speed of light in different media. We have here the materials or medium and then the speed of that. Then, for sample problem number 1, what is the index of refraction of a transparent material in which light travels at 229 million meters per second? So, 229 million meters per second is an ice. So, we have here next the given values to solve that. We have here the speed of light in a vacuum, which is 3.0 times 10 raised to 8 meters per second. And then the speed of light in a given material, which is the ice, is 2.29 times 10 raised to 8 meters per second. So, that is 229 million rather. So, expressed in scientific notation, that is raised to 8, 3, 6, 7, 8, 2.29 times 10 raised to 8 meters per second. Then solution substitution. Index of refraction is equivalent to the speed of light in a vacuum over the speed of light in a given material. So you will have here the speed of light for C in a vacuum, which is 3.0 times 10 raised to 8 meters per second. And then the speed of light as it bends in the ice is 2.29 times 10 raised to 8 meters per second. Then cancel, since they have the same exponent, 10 raised to 8, then meters per second cancel as well. Then divide 3.0 divided by 2.29, you will have the index of refraction or refractive index of 1.3. That is the answer. And then sample problem number 2. What is the index of refraction of a flint in which light travels at 180 million? So you have the given value of the speed of light in a vacuum, which is 3.0 times 10 raised to 8 meters per second. And then the speed of the light in a given material, such as the flint, based on the problem, is 1.8 times 10 raised to 8 meters per second from 180 million, expressed in scientific notation. And then the solution is refractive index is equivalent to the speed of light in a vacuum over the speed of light on a given material. Here we will be using the flint. So substitution, the speed of light in a vacuum again is 3.0 times 10 raised to 8 meters per second. And then the speed of light in a flint material is 1.8 times 10 raised to 8 meters per second. Cancel 10 raised to 8 meters per second, numerator, denominator. And then you will be left out with the 3.0 and 1.8. Divide that, you will have the refractive index of 1.67. That is the answer. Now for your assignment, this will be submitted this Saturday, this week as well. So that is all for this lecture video on the index of refraction.